recording this one so that you guys can go back and watch this one later, but make sure that you had put A, B, and C right here, and then put D and E over here, because that'll be the easiest way to kind of keep track of what we're actually subtracting and dividing, all right? So the first part was saying, because in the end, we needed percent water of the original hydrated crystal. So in order to get to this percent, you had to do these steps first. So we had water, which was B minus C. It was our wet salt, the hydrate, minus the dry hydrate. All right, so the anhydrous part. So B minus C. So you had 22.41 minus 22.14. All right. So you did this calculation yesterday. You figured out what the water was that left, right? Wet minus dry equals what was wet, the water part, right? So when you subtracted those two, thank you. I already had it half typed in, sorry. 0.27 is absolutely correct. All right. Then we had to get the hydrated crystal. So that would mean we would want the wet salt minus just the container. So you would take B minus A. So 22.41 minus 21.53. So when you subtracted those two, 0.88. Okay? So in order to do the percent water, it's kind of like our percent composition, part over whole, right? But we're just going to be using what we just got, right? We want the water over hydrate. Okay? So what that means is we're going to take D divided by E. Okay? D divided by E. So I'm going to take my 0.27. I'm going to divide it by our answer from E, which was 0.88. And then we're going to multiply that by 100. So when you do that, you should get like 0.3068, and you're going to multiply that by 100 to get 30. We can round up to 7. 30.7%.